Okay, so let's start from problem 11. So we did problems 1 to 10. Now let's look at number 11. Select the correct electron configuration for sulfur. Z equals 16. Okay, let's see how we can write the electron configuration. Sulfur is 16. Now, this is a good aid for you to figure out how to fill the electrons. Okay, let's see. Now, we can expand it a little bit. So what these arrows showing us is the first orbital that is being filled is the s orbital. After s orbital is being filled, it's going to go to fill up this 2s orbital. After the 2s orbital is being filled up, it goes to the 2p. And then the 2p then goes to the 3s and then come back to fill up 3p. 3p and then 4s. After 4s, it goes back here to start again 3d. 4p, 5s. After 5s comes to fill up 4d, 5p, 6s, and then after 6s it goes to 4f, 5d, 6p, 7s, and then comes the 5f. Okay, and one more thing that you need to remember when you are filling up, how many electrons each orbital can hold maximum. S can hold maximum 2 electrons. P can hold maximum 6 electrons because there are 3 possible P subshells. For that you can hold 6. And there are D subshells, 5 of D subshells. 5 times 10, 5 times 2, 10 electrons can hold by D orbitals. And then the F orbitals has 7 subshells. Remember, F can have the values -3 to +3. There are 7 subshells. So 7 times 2, 14 electrons. Each orbital can hold maximum. So when you are filling up, you have to fill the electrons in the orbitals according to these numbers. Now we are looking at sulfur atomic number 16. Now let's use this method to fill up sulfur 16 electrons and see what is the electron configuration. Always the first one that's going to fill is the 1s. So sulfur, the first one going to be 1s, and s can hold maximum how many electrons? 2. Once you are done with that, you're going to go to the 2s. Once s is done, you go to 2s. Again another s orbital. How many electrons maximum s can hold? 2. So you write it down, 2s2. And then is the after 2s. What is after 2s? After 2s, it is 2p. You go to 2p. How many electrons maximum p can hold? 6. So you put 2p6 because we are not completed 16 yet. So up to now, how many electrons have we filled? 1s2, 2s2, 2p6. We have filled up 10. We need 6 more. After 2p, what comes after 2p? 3s. So you're going to put your 3s. How many s can hold maximum? 2. So 3s2. After 3s, what comes after 3s? That's going to be 3p. Okay, now P can hold maximum 6. Let's see how many we have filled up so far. So 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 12. We have to go up to 16. So 16 minus 12, how much is that? 4. So for 3p, you don't have to put all 6. You only need to fill up to 4. So then it would make it 3p4. So the electron configuration for the atomic number 16 would be 1s2, 2s2, 2p6, 3s2, 3p4. And just to make sure that we have filled the correct number, you can go and count these electrons in the sublevels. 2 plus 2, 4 plus 6, 10, 12, 12 plus 14, not 14, 12 plus 4, 16. Right? So now this is the electron configuration for Z equals 16 sulfur. Okay, and then the next one, so I'm going to go ahead and clear this up. The next one is asking what is the electron configuration for copper. Copper atomic number given as 29. Okay, let's do this. We were given the condensed electron configuration for that. Let's see. So we can refer to the periodic table. Copper right here. Okay, this is the copper. So we can do argon, okay, and then that would be the noble gas prior to copper. And then copper is in the fourth period, 1, 2, 3, 4. So the fourth period, this is 4s1, 4s2. After 4s, what comes after 4s? After 4s, it's the 3d. So you see here 4s, you go along, that's the 3d. And then the copper is in the D block. So you're going to count how many 3D electrons need to fill up to reach copper. Okay. So 4s2, 3d1, 2, 3, 4, 5, 6, 7, 8, 9. 3d9. So we can go ahead and write that down. Copper 29 would be noble gas configuration prior to copper is argon, and then 4s2, 3d9. Now I explained this in the video, in the lecture video, that when the copper or any element is one less than being completely filled like a d orbital, it would do something special. So let's see our d orbitals. So these are d orbitals. How many d orbitals possible? 5d orbitals possible. 1, 2, 3, 4, 5. So this is 3d sublevel. There are 5 subshells for d, and there are 9 electrons. So 1, and before that let me go ahead and write down 4s. In the 4s level there are 2 electrons. So the d level we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there is something happens when the d electrons are completely filled. Right now it has only 9. What's going to happen is one of the s electrons, one of these s electrons jumps onto the d orbital and make it a complete 3d10. That gives added stability for the copper atom. Okay, when this happens, your d electrons are going to be like that. The 5 orbitals, 1, 2, 3, 4, 5. Now it has 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is instead of 3d9, 3d10. Now the amount of 4s is going to be now 4s1. So instead of copper being 4s2, 3d9, copper would be argon 4s1, 3d10. Okay, the same thing happen when you come to chromium. Chromium is 3d4, 4s2, 3d4. So this is d electrons completely filled, and also it has an added stability when the d electrons are half filled. Okay, what I mean by that, let me explain you. For chromium, chromium is atomic number 24. Okay, if you write down its electron configuration, condensed electron configuration for chromium, atomic number 24, it would be argon 4s2, 3d4. That's the electron configuration for chromium. But again, the d electron, so this is going to be your 4s, and then this is going to be your d. 1, 2, 3, 4, 5. Okay, this is going to be your 3D. So 3D has 4s has 2 electrons, 4s2, 3D has 4, 1, 2, 3, 4. So again, when the D is half filled, that also has an added stability. So one of the electrons from the 4s jumps onto the empty D orbital, making 4s1 and 3d5. So then we have electrons 1, 2, 3, 4, 5. We'll make it 3d5. So the chromium, instead of 4s2, 3d4, chromium would be 4s1, 3d5. So the d electrons have added stability when they are half filled or when they are completely filled. Okay, those are the two exceptions that you would want to know. Okay, so the next question, number 13. Which of the following sublevels filled last? Is it the 3D, 4S, 4P, 4D, 5S? Now to this one you can refer to this chart over here. Okay, so the given sublevels are, it's asking which sub-level filled last. Is it the 3D, is it the 4S, 4P, 4D or 5S? Now we can refer to this one. Where is the 3D? So 3D is right here. You can locate 3D. 3D is right there. And 4S. 4S is right here. 4P is right there. And then the 4D is right there. 5S going to be here. Now, which one filled the last? First is the 4S, then the 3D. This is the order of filling. 4S, 3D, 4P, 5S, and then goes to the 4D. So the one that fills the last is 4D. Okay, so the correct answer for number 13 is 4D, which is E. And then number 14, select the correct electron configuration for tellurium. Atomic number 52. So tellurium, let's locate our tellurium in the periodic table. Tellurium, Te, right there. Okay, condensed electron configuration. The noble gas prior to tellurium is krypton. And then you go to your main period, which is going to be 1, 2, 3, 4, 5. Fifth period is where we find tellurium. Prior to go to tellurium, after krypton, it's going to be the 5s, 5s2. Always D starts 1 less than the principal quantum number. So this is the fifth period. If this is the fifth S, your D going to be 1 less than that, because the first time that the D start filling is 3D. So this is the 3D series and this is the 4D. So 5s2, 3D. So all the D orbitals are filled up. So 5D, not 5D, sorry. 5s2, 4d10 filled, and then the p electrons start filling up. P electrons are going to be the same as the s orbital, principal quantum number 5. 5p1, 5p2, 5p3, 5p4. Okay, so that would be krypton, 5s2, 4d10, 5p4. And also you can refer to this chart as well. Right, so you locate where your tellurium is. That's going to be over here, right? So that means after the noble gas, krypton, 5s2, then comes the 4d, all the d's being filled, 4d10, 5p1, 5p2, 5p3, 5p4. Okay, so that is the tellurium. So for the tellurium 52. That's going to be 5s2, 4d10, and 5p4. I forgot to write the noble gas prior to that, krypton. 5s2, 4d10, 5p4. Okay. And also you can count the number of electrons and see if you get 52. Now the krypton. So you can look at the krypton. Krypton has, the atomic number for krypton is 36. Plus 2 plus 10 plus 4. 36 plus 2, 38 plus 10, 48 plus 4, 52. So it has that number of electrons. Okay. Okay. The next one. Alright, number 15. The electronic structure 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8 refers to the ground state of. Now the easiest way you can find is you count the number of electrons in each subshell. So 1 is 2, meaning there are 2. So 2 plus 2, 4 plus 6, 10. 10 plus 2, 12. 12 plus 6, 18. 18 plus 2, 20. 20 plus 8, 28. You look at the periodic table. What is number 28? Nickel. Right? So that is nickel. And also then you can go to the periodic table and see what is the configuration for that. That's going to be argon 3d8, 4s2, 4s2, 3d8. Okay? That is nickel. And number 16. How many valence electrons are there in an atom with the electron configuration? You have the noble gas Ns2, N minus 1, D8. Now, N is the principal quantum number and N minus 1 is the D electrons. Remember, if the principal quantum number is 4, 4s2, N minus 1 is 3. The D is going to be 1 less than that. That's why N minus 1, D8. Let me write it in my PowerPoint. Ns2, N minus 1. So what's given to us was Ns2, N minus 1, D8. And it is asking how many valence electrons are there in this configuration. N is the principal quantum number. D going to be 1 less than that. Now the valence electrons are going to be that has S and P, if you do have S and P. But here we have only S. So the 2, these 2 are going to be valence electron. That is the highest quantum number. And also if the D is not completely filled, now there are 8 electrons. When would be the D going to be completely be filled? When D, if you find D equals 10, like if you are given a configuration that the D is completely filled as D10, then you do not consider this as valence electrons. But if it is a number less than 10, you would consider D as valence electrons, meaning the outermost electrons. So 2 plus, so here the 8 electrons are less than 10. So 2 plus 8 is 10. So all of these Ns2 and N minus 1 D level electrons are considered valence electrons. So there are 10 valence electrons. Okay. So the correct answer for number 16 is 10. And then the next one, which of the following sets of elements have the noble gas Ns2, Np2 valence electrons? Now if it is Ns2, Np2, okay, what is the group number for that? How many what is the total number of valence electrons in Ns2, Np2? Ns2, Np2. What is the total number of valence electrons in this configuration? S and P would be the same principal quantum number. So S and P both are going to be your valence electrons. So 2 plus 2, there are 4 valence electrons. 4 valence electrons are in which group? It's in the group 4, right? S2P2. S2P2. You see here? S2P, these are valence electrons, S2P2. All Ns2P2. So this is group 4. There are 4 valence electron, 2 plus 2, 4, fourth group. So then you choose which elements are belong to group 4 from the given set. So that is going to be carbon, silicon, germanium, tin, lead. They are in group 4. Okay, that's how you find which of the following sets of electrons have the noble gas configuration and this valence electron configuration. And then the number 18. So the correct answer for 17 is D. 18. How many valence electrons are there in an atom with the electron configuration noble gas Ns2, N-1, D10, Np3? Now in this one, it's given to us configuration as Ns2, noble gas configuration, and then you have Ns2, N-1, D10, and then we have Np3. Now in this case, the D is completely filled. If the D is completely filled with D10, you don't consider them as your valence electrons. So then your valence electrons are going to be highest number of the N and P together. Excuse me. So we have 2 and 3, 2 plus 3 equals 5. So the valence electrons are going to be 5 for number 18. Okay. And then the number 19. Which of the following elements has the largest atomic size? So you have sulfur, radon, barium, polonium, and calcium. Now we have to locate where they are in the periodic table. Okay, so you can refer to the periodic table. We have the periodic table here also. Also we have a periodic table here. So our elements are sulfur, radon, barium, polonium, calcium. Now what is the trend in the periodic table in terms of atomic size? The size decreases as you go across the periodic table, meaning this side has higher atomic size. Along the period it decreases. And if you go down the periodic table as the principal quantum number increases, you will see the size increases. Okay. Now the one of the elements that we have in this series is sulfur. Sulfur. So sulfur is here. Okay, sulfur is there. So let's see, sulfur is here. That is the sulfur. And then we have radon, Rn. Where is Rn? I'm having trouble finding Rn. Radon. Okay. I thought I found it. But anyway, let's look at the other ones. So barium, I know where barium is. Barium is here. And then polonium. Polonium is over here. And then, oh, radon found it. Yes, Rn. Good. Radon is there. And then, what's the other? Calcium. Calcium is there. So we located our 5 elements. So what happens as you go across the periodic table? The size decreases. As you go down, size increases. So obviously calcium and sulfur out. And then you look at barium, polonium, radon. They are in the same period. So as we go along the periodic table, size decreases. Right? So then the biggest atom is going to be barium. Okay, largest atomic size. And then the next one, 20, which of the following fourth period elements has the smallest atomic radius? Fourth period. So we are looking at 1, 2, 3, 4. Fourth period atoms. We have krypton, copper, germanium, potassium, titanium. Titanium? Yeah. Fourth period. Krypton is right here. And if the krypton is right there, smallest atomic radius obviously going to be krypton, because that is the noble gas. As we go across the periodic table, size decreases. All of them are in the fourth period. Isn't that what it said? Fourth period. Krypton is there. We can go ahead and circle them. Krypton is here. Copper is here. Titanium is here. And then we have a germanium, Ge. Okay. Anything else I'm missing? Potassium. Okay, they are all in the fourth period. So as you go across the periodic table, effective nuclear charge decreases, so the atomic size decreases. Okay, so the krypton would be the smallest atom. And then the next one, number 21. Which of the following elements has the smallest atomic radius? The smallest atomic radius, lithium. So we have lithium here, and then we have xenon, and then we have strontium right there, neon right there, and rubidium is right here. Now, which one is the smallest one? Of course, like we said, the trend is size decreases as you go across, and these are going to be increasing, so they are out. So this is the fourth period. So as you go down, the size increases. So between neon and xenon, which one is the smallest? It's the neon. And between neon and lithium, which one is the smallest? Neon. So the smallest atomic radius would be neon. Okay. And then the number 22. Which one of the following correctly represent the process related to the ionization energy of X? Normally, the ionization energy is removal of an electron from a gaseous atom. 1 mole of gaseous atom. Okay. Okay. So if you have X gas, and 1 mole of X gas lose an electron and become +1 charge gaseous, leaving 1 electron. So this is the process of ionization energy, and we call this as ionization energy. The energy needed to remove an electron from a 1 mole of a gaseous atom to make 1 mole of gaseous positive ion. Okay, so the correct choice for this is going to be 22A. And then number 23. Number 23. Let me show you the question. When comparing the successive ionization energy of an element, unusually big increase in ionization energy is seen when the 8th electron of it is removed. We don't know where the 8th electron is, so we cannot say anything about that. The first co-electron is removed, the last valence electron removed, the first valence removed, the second valence. So it is going to be the first co-electron is removed. Co-electrons are the ones that we touched after we remove all the valence electrons, meaning we are going to disturb a noble gas configuration, similar to a noble gas configuration in the atom after all the valence electrons are removed. That is pretty stable. It's difficult to remove. We have to give a lot of energy. So we normally see a large increase in ionization energy when the first co-electron is being removed. That is 23B. And number 24. Elements with the highest first ionization energies are found. Highest first ionization energy means it would become difficult for it to remove an electron. Normally, low ionization energies are available for the metals to form metal cations. And it would be harder for nonmetals to lose an electron because they are electronegative. They like to gain electrons. Okay, so highest first ionization energies are found in the upper right region of the periodic table. So they are the more electronegative. They are very closer to the nucleus. They like to gain an electron instead of losing an electron. Okay, it's the 24. The correct answer is E. 25. Which one of the following equations correctly represent the process involved in the electron affinity? So electron affinity means gaining an electron. Okay, so the number we are looking at, number 25, electron affinity is gaining an electron. So let's say you have a gaseous atom, X gaseous atom, gain one electron. When they gain, it forms a negative one charge, a gaseous ion. So X gas take one electron and become X minus. So that is the correct choice for that is B. Okay, 25B. X gas take one electron and become X minus. And then the number 26. Which of the following elements has the largest first ionization energy? Largest first ionization energy. Let's look at the periodic table. Okay. Alright, what we have here, we have tellurium. And then we have sodium, and then we have chlorine, and then we have bromine and calcium. So the trend in ionization energy is ionization energy increases as you go across the periodic table. As you go across, ionization energy increases, and as you go down, ionization energy decreases, meaning it would become easier for it to lose an electron. Now, sodium, chlorine, right? As you go down, ionization energy decreases. So the chlorine would be having the highest ionization energy, first ionization energy, because as you go down it decreases, and between chlorine and sodium is a metal, it would be easy for it to make a cation, whereas chlorine is a non-metal, would find it hard to lose an electron. So the highest or the largest first ionization energy would have, the element would be chlorine. Okay. Okay, number 26. Elements with first ionization energies and electron affinities generally forms cations. So cations means the metal side of the periodic table, and they normally have very low ionization energies, first ionization energy. So that's why metal lose electrons. So we have to choose the one that says low. So either B and C. And then electron affinities. They don't have electron affinity much, meaning if the electron affinity is very large, negative value, meaning it's easy to gain an electron. But if it is less negative and more positive side, meaning it's harder for that element to gain an electron. So then it would be C, low, elements with low first ionization energies and positive or slightly negative electrons affinities generally forms cations. So 27 would be C. Okay. And 28. Select the element with the most negative electron affinity, meaning accept an electron most readily. Okay. Let's look at the periodic table and see where are the elements located. So we have fluorine. We all know where the fluorine is, and we have neon. Neon is here. Neon, carbon, hydrogen, carbon, lithium, fluorine, right there. It's asking Select the element with the most negative electron affinity. Accept an electron most readily. Which one do you think? Normally, non-metals have very large negative electron affinities. So neon is a noble gas. It doesn't want to lose or gain an electron. Okay, so because of that, neon is out. And then we are left with hydrogen, lithium, carbon, fluorine. Which one would be more electronegative, that has a more electron affinity? That is going to be fluorine. Okay, so fluorine, because the electronegativity increases as we go across the periodic table, and then electron affinity become large negative as we go across the periodic table. It would be the fluorine. Okay, so next, what is the correct order of decreasing size of the following ions? Now, if you look closely, we call them as isoelectronic, meaning they have the same number of electrons. P3 minus, the phosphorus atomic number is 15. P3 minus, meaning it has gained 3 electrons, so phosphorus 15 plus 3 electrons, 18 electrons phosphorus has. Chloride, Cl minus, chlorine atomic number 17, minus 1, meaning it has gained electrons, so 18. So potassium also, so the elements that we are talking about, these are the ions that are given to us. Calcium 2 plus, we are given potassium plus, we are given Cl minus and P3 minus. So calcium, atomic number for calcium is 20. Calcium 2 plus, meaning has lost 2 electrons, so calcium 2 plus is 18. And then the potassium is 19, lost an electron, that is 18. Chloride is 17, gained an electron to make Cl minus 18. Phosphorus by itself 15, and then 3 minus is 18. So they are all, these ions are isoelectronic. Okay, in an isoelectronic series, the more negative the ion is, the electron cloud gets bigger. Right, so electron clouds get bigger, meaning it has more electrons, so now the size increases. So between all these four, P3 minus would be the largest atom. Which one would be the next one? It would be Cl minus, and then it would be K plus, plus 1 charge. The more positive charge, the electrons are more pulled towards the nucleus and it would become smaller in size. So potassium is plus 1, calcium is 2 plus. So the more positive charge, the ion will become smaller. And this is for the isoelectronic series, meaning they have the same number of electrons. So the correct order would be P3 minus, Cl minus, K plus 2, calcium 2 plus for number 29. Okay, so the correct answer is D. And then the next one also similar to that, the last one. Consider the set of isoelectronic atoms and ions A2 minus, B minus, C, D plus, E2 plus. Again, this talks about an isoelectronic series. Same number of electrons. We are given the numbers or the charges as A2 minus, you have B minus, C, D plus, E plus 2, and they are isoelectronic. Okay, so then the biggest charge or the biggest negative ion would be the more bigger element or the ion, A2 minus. A2 minus would be the biggest, then the B minus, then the C, then the D plus, and then E2 plus would be the smallest guy. Okay, so that is going to be the order. Correct answer for that is D for 30. Okay, and if I quickly give you the answers for the questions, 1 would be C, 2D, 3D, 4C, 5D, 6D, 7D, 8C, 9B, 10B, 11E, 12A, 13E, 14E, 15D, 16D, 17D, 18, C, 19, C, 20, A, 21, D, 22, A, 23, B, 24, E, 25, B, 26, C, 28, E, 29, D, 30, D. Okay, all right, we're done. Bye bye.